So we can put this on our archived Colloquium site. But welcome, I'm Dr. Wes Hines. I'm the Nuclear Engineering Department Head. I'm also the Director of Record for NE 501, which is our senior seminar. So let me just jump to and take care of some administrative details with senior seminar first. The syllabus is on your Canvas site. So for all the students, if you want to see the syllabus, go to the Canvas site. You can, although at the registrar site, it says at this meeting time and some other time, we've already set up our speakers for a normal time, and I wasn't going to go through and ask everybody to change their schedules throughout the year. So we're going to meet from 1:30 to 2:30. Hopefully that's not a conflict for anybody. If it is, these will be recorded and put up on our site. This is the list of speakers for the semester. Lots of really good speakers, a lot of diversity in these speakers. We also have a town hall meeting near the end, and then we have ANS meetings. We always cancel it on ANS meeting week. And then we have Thanksgiving week, and we usually cancel it the day before Thanksgiving. And then after Thanksgiving, it's finals. So there's only 12, and students are required to attend 75% of them, so you need to attend 9. If you miss one and you want to watch it later, then you have to write me a 1-page summary and turn it into me through the Canvas. It says through email here, but turn it in through Canvas before the next scheduled seminar meeting. This first meeting, the safety meeting, is required for everybody. I don't know if I communicated that well in the syllabus, but I'm going to have, if people didn't show up to this first seminar, the safety seminar, all the students will have to watch this first safety seminar. Okay, let me stop share on that. Do any students have a question? Everybody's muted now, but I can click and unmute you if you have a question about the seminar. This is the first year we've made all this, we've done seminars online, but I think we have a lot of experience with how to do things online now. So I don't see anybody with a question. Okay, so we'll go ahead. If you do have a question, feel free to email me, or feel free to put a question in the chat box. That'll work. Okay, so today is every year we start off our first seminar as a safety seminar. This year I kind of split it up as 3 mini safety seminars. We have 3 different people who are going to speak, and each of them will speak for 10 to 15 minutes, and we'll try to save all the questions to the end. Excuse me. I think I'm allergic to teaching. I haven't taught for so long. So we're going to have Marsha Smith, who's the radiation safety officer. We're going to have Scott Moser, who is a supervisor in the laboratory safety services of environment, health, and safety here at UT. And then we're going to have Eric Lukosi talk a little bit about really about safety related to COVID and related to the pandemic. So I'm going to start off with Marsha. Marsha is the radiation safety officer for UT, as I said. She started working at the university in the radiation safety department in 2005, so she's been here 15 years. She has a Bachelor of Science in Environmental Science and an MBA, both from the University of Tennessee, Knoxville. Welcome, Marsha.
Thank you, Dr. Hines. So I would like to welcome everyone back. I see some familiar names here in the list, so I know that some of you have worked with radiation safety in the past or in previous semesters, and there's some new names here too, so welcome everyone. I'm glad you're back and glad we're here starting a new fall semester. So I'm Marsha Smith. I'm the radiation safety officer, and so I'm overseeing the radiation safety unit within environmental health and safety. And so Scott is my colleague, and you'll hear from Scott here in a little bit about general lab safety. But with radiation safety, we kind of have our own little standalone program due to the requirements and regulations that are placed to make sure we're all safe when we work with ionizing radiation sources. So for radiation safety, we oversee the safe use of radioactive materials, and that would be loose materials, liquid solids, or sealed sources, which your department has many sealed sources. So I know some of you have done some work with sealed sources, and sealed are the sources that are contained where contamination shouldn't be an issue unless it's been damaged. We also oversee X-ray sources or any kind of machine created ionizing radiation, so any kind of device where we have any concerns with ionizing radiation. And we also have the high-powered laser safety program. So if you have a class 3B or 4 laser, we would like to come check it out just to make sure we have right enclosures, right training, right, everything that we need to make sure everyone is safe when they're around these objects. So I would say for us, Dr. Hines asked to kind of hit the highlights of what the important parts are for our program or what you all should know kind of going forward. So, with all of these, with no matter the type of ionizing or non-ionizing type of source you may be working around for research or teaching or whatever your projects may be, for us, the important thing is training. So we want you to complete some sort of hazard training before you begin working with those types of sources. We host most of our training programs online on Canvas, and it's one of those things where you can't just log into Canvas and find the link to us. We want to know who you are and which lab you're going to be working in. So we want everyone to contact us. And so our contact is radiationsafety@utk.edu is our email address. And faculty members and everyone can kind of help, and the department assets can help too. But our goal is for sealed source training, X-ray training, or laser, all that is on Canvas. So we're happy to enroll you. We're happy to help you get through it however. And so we have those modules on Canvas. For our in-person training, we want to see you in person if you're going to be working with loose materials. And so traditionally we did this as like a 2 to 3 hour class, which seems kind of long, but there's kind of a lot to it. That's how we did it pre-COVID. And now that we're COVID, we've switched things up some where most of it is a self-study, but at some point we still want to see you. So we want you to come in because we would like to show you and demonstrate how to use survey instruments to look for contamination, and just kind of some general point. We like to build a relationship with you too. So it's important for us to meet you and understand what you're doing and kind of make that point with you. So for training, we want that to happen before you begin your research or your teaching activities. And so all the links to our training classes, including how you can get a hold of us and all that, is on our website. So our website, easy enough, is radiationsafety.utk.edu. And you can find our training schedule. We're trying to do some, either the self-study, but we can also do our training for radioactive materials on Zoom. And then also there's information how to contact us about Canvas. So training's big for us. The second thing that's big for us is making sure that we have some idea about people's radiation exposure here on campus. If they're working with radiation sources, if you're taking a class that involves radiation sources, no matter what you're doing here, we need to keep up and be aware of how much radiation you've been exposed to and what your dose would be. There are occupational dose limits that we are required to meet, the university is required to meet. So it's important too that in this process of getting training, we'll also contact you and discuss what we need to do for dosimetry. And so we can issue, dosimeters where you need it here in 2 weeks. We can, make sure you have a dosimeter if you need it tomorrow. So we're here to work with you to make sure you have what you need. In addition, there are some situations, especially when it comes to our graduate teaching classes, where we do have some hands-on work with some radioactive check sources. So some of these controlled experiments and some of our use with X-ray devices, were, instead of wearing dosimeters, we're able to provide you with a dose calculation. So we say worst case scenario, this would be what you've been exposed to. So for some of our classes too, and some of our information, we'll share that with faculty members. We'll try to send that to the students. We'll try to make that available so you have some idea of what your worst case, essentially, what your radiation dose is from your activities. Another step with us that's probably good and important for you all to know as you're planning projects or as you're moving forward is that with all of the radiation sources, all of it is tracked and maintained by our unit. We've got a radiation safety committee for the university that issues permits and reviews experiments and uses of radiation sources on campus. So when we're doing research and we have, we're doing something new and unique, we just need to make sure that what we're planning on doing is within whatever the faculty member permissions are. And we can kind of help work that through. That's not an impediment, but some of our work areas have, some faculty have permissions for some sources and some don't. And so we'll help you work through that so you can do that. But also probably the more important part of this is experimental reviews. So a lot of times, especially nuclear engineering, because you all have sealed sources, someone may be allowed to possess, a cesium source, but the way you're going to use it may be different. You may want to use more shielding, maybe want to use less. You may end up in a laboratory where your colleagues will be there. So there's lots of different scenarios, and each experiment kind of creates its own. So we're here to do experimental reviews too. So for some faculty, they'll submit us, or they'll have their students, submit sort of a research protocol, sort of SOP for whatever activity they're doing. So we'll review those and work that through. But really the secondary thing I want to say to you is that we're here to help. So if you're doing something, you decide whatever my plan was, I'm needing to change it. I'm not getting the results I want. This isn't working. We're here to help you figure out how you can do what you need to do in a safe way. So contact us. We're available and we're here to help you out. And so to kind of round it out, really, we're here to support you all. I know I've met many of you all, at least I know through emails, if not in person. And we want to make sure you're successful with whatever your projects are, your tasks, your job, whatever you're doing here. We want to make sure you're successful and that you're doing it in a safe way. So for us, our kind of core things are making sure everyone has some sort of hazard training so that they're aware of the radiation hazards. And this is true for high-powered laser systems. We want to make sure, even if it's all enclosed, if it's a high-powered system, that we have provided you some sort of hazard instruction. We want to make sure that your radiation dose is monitored. And then we want to be here to support you, how we can, to make sure your operations are safe. For our lasers, we go through, just to kind of touch point on those. Generally speaking, we'll do an initial hazard assessment on those. And then it's only really kind of, if there's major changes with the way the laser is set up, then we really don't need to see the laser again for, we're going on around 2 years, just trying to make sure that we're keeping up the training and all that with the individuals. But overall, most of these lasers, once they have a general setup, we're pretty good to go with the safety features. And that's all I prepared for today. So I'll pass this off to Dr. Hines again. And I'm happy to take any questions you all have.
Yeah, let's save the questions to the end, just because
Okay.
we'll make sure we get through all three speakers. If we get into all these questions, then I have to cut someone off, and I'd rather just make sure that we get through everybody. Okay, well, thanks, Marsha. Just something else, I put some things into chat. If you come into the seminar late, then you need to put a note in chat that you're here, because I've already taken attendance. If you call in on a phone, put a note in chat, or give me send me an email saying, hey, this phone number was me. That way I can take attendance. When people call in and all I get is a phone number, I don't know who that is. Okay, so let's go on to our second speaker. Our second speaker is Scott Moser. He works for the Environmental Health and Safety here at UT. He's the Supervisor in Laboratory Safety Services, Chemical Safety, and has been at UTK for 18 years. So he's got a couple years on Marsha. The first 14 he spent in active research on campus. He has a Bachelor of Science in Microbiology from UTK, and he's currently the Senior Chemical Safety Contact at EHS. Scott, thank you.
Screen here. So can everybody see my screen now? Let's see. Go full screen here. All right. Yeah, let's do it in presenter mode. So yeah, basically just gonna run through my slides pretty quickly here. So here at Lab Safety Services, we kind of work in conjunction with the Hazardous Waste Program and radiation safety to cover most things in the lab. Lab Safety Services purview is actually chemical hygiene or chemical hazards, biohazards, and physical hazards, which are kind of electrical safety and things like that. So, and then that we kind of deal with all the research, teaching, diagnostic support shops, and maker spaces on campus. And kind of what Marsha was saying, there are several committees on campus that we work through. The Campus Safety Committee, which Laboratory Safety Committee is part of that. The Biosafety Committee, High Hazard Committee is in progress. We're trying to get this up and running. That will review a lot of the high chemical hazards on campus and help get kind of more kind of SOPs that are more campus-wide instead of just individual. And then Marsha was talking about the Radiation Safety Committee earlier. So we do have a lot of regulatory landscape. We call it the alphabet soup that we deal with. Just different agencies that deal with safety, and it can be broken down into different categories: fire and life safety, occupational, environmental, transportation, as well as granting agencies kind of look to us now to make sure that people are doing research safely before they'll kind of sign off on giving them money to do the research. So then just real quickly, roles and responsibilities. I won't bore you by reading all this, but basically UT has a statement of commitment of safety to employees and students and staff on campus. So that's kind of new this year. And then just basic leadership roles and responsibilities. Again, a lot of words there, but I have made these slides available to Dr. Hines, and you can send them out afterwards if you need to read over these things again. But I will stop on just lab personnel, mainly students and staff, or students. Basically, that you will make all necessary steps to protect yourselves and others from hazards and abide by safe work practices. And we cover all these things in our training, which I'll give the links to at the end here. And one of the main things that I want to reiterate or focus on is this last one is reporting potentially unsafe conditions or health hazards, as well as injuries or accidents, and as well as near misses. We at EHS need to know about these things. It helps us learn how to make things safer on campus. So if accidents do happen, don't feel like you did anything wrong. Let us know, and we can help make the campus safer as a whole. So, and then EHS role on campus. The main thing here is collaborate with campus leadership to provide guidance in identifying and evaluating and correcting health and safety hazards. Kind of go over that a little bit more on the next slide. And then we partner and support the PIs in preparation of their training materials, chemical hygiene plans, safety systems, and monitoring as needed. So, and again, like Marsha was saying, we're here to help. That's our main goal on campus, is to help the faculty and students perform their jobs safely. And we do this by risk assessments, inspections, or we like to call them safety reviews. Inspection makes it sound like we're trying to catch you doing something wrong. And Dr. Hines wanted me to kind of go over the three main findings that we had last year for the departmental safety reviews. And the top one was the weekly eye wash testing. Basically, you're supposed to test your eye washes on a weekly basis. So just make sure you flush those and document that. The second one was just hazardous waste issues. Either the waste was not properly labeled with the yellow hazardous waste sticker. Chemicals were not spelled out, or they need to be spelled out. No formulas on the waste labels, and waste containers need to be kept closed unless you're actively adding something to them. And then the third kind of finding that we found most in the department was the compressed gas cylinders need to be capped when not in use. So basically, if it's not in use, and need to have the regulator off and the safety cap back on the compressed gas cylinder. And all these things we're really trying to develop a safety culture on campus, and these things, the relationship that we build with the faculty and students, as well as shared values and meaning, can kind of change the culture on campus. And that's really what we want to try to do, is to get you guys to think more in a safety mindset instead of just do's and don'ts. Kind of look at problems as they come up and have a way to kind of a mindset of thinking safety first. So, and that kind of goes into this next section about hazards. So there are 4 main hazard classes of physical, biological, chemical, and radiological. Again, that's with laboratory safety services kind of handles those top 3, and Marsha and her group handle the radiological safety. And basically understanding the difference between hazard and risk. So a hazard is like something bad can happen, and the likelihood of that happening, as well as the hazard of it, kind of leads into risk. So we try to kind of get people to look at a hazard as kind of whether or not there's a high likelihood of it occurring. We do want to make sure that people understand hazard, and then try to mitigate those hazards as much as possible. So we kind of look at it as a continuum of identifying what your hazards are, then controlling them, and then preparing for emergencies as much as possible. And so the RAMP acronym was developed by the American Chemical Society, and it's a pretty good way to look at handling hazards and risks. So you recognize the hazards, you assess the hazards, then you minimize the risk from the hazards with controls, and then prepare for emergencies. So the next slide, we just kind of walk you through just a basic chemical perspective. So you have a hazard in the lab by the pictograms on the bottle, and then you kind of assess by using the danger or warning caution messages that are found on your SDS sheets. And then you develop SOPs for handling that chemical. And as part of the SOPs, you prepare for different problems that might occur. So, and then we, as EHS professionals, kind of talk about the hierarchy of risk controls. Basically, these are ways that you can mitigate the risk hazard. So there are 4 main ones. We won't make you rank them, but the top one is elimination. Basically, if you can eliminate the hazard, then you've done a good job. Then engineering controls, which are like your chemical fume hoods and other building type controls. Then administrative controls, which is kind of the SOPs for handling that chemical. You can kind of make your own rules to handle that chemical properly. And the kind of the least effective one is the last line of defense is the personal protective equipment. So, and so we kind of go over PPE requirements. So your PI should train you on kind of the PPE requirements of when is it necessary, what PPE is necessary for performing specific tasks, how to properly wear and adjust the PPE. The limitations of the PPE are pretty important, like what doesn't it protect you from, and then how to properly care and maintain your PPE. And then kind of quickly, kind of what I was talking about earlier is going over accidents and near misses. So an accident is obviously an unplanned event that results in injury or property damage. And then a near miss is an incident, be it for a slight shift in time or position, could easily result in injury or damage. And most of the times what happens is a near miss occurs, but we like to know about the near misses just as easily. Again, don't be afraid if you make errors or mistakes. Everybody does it. We're here to make sure that if an error or mistake occurs, that the consequences are as low as possible. We want to make sure that everyone goes home as healthy and whole as they arrived at work. So, and just kind of some factors of accidents, kind of rushing through things. You're tired, you're distracted, or you think you know how to do the experiment, and you kind of become complacent. So, and then there's kind of the model, Swiss cheese model of accident cause. Basically, everything has to line up before the accident occurs. So, and then kind of the defense in depth, kind of just taking one of those things out makes it easier for an accident to occur. And then that leads us into kind of two incidents that happened on campus. Both were hydrofluoric acid spills. Hydrofluoric acid's highly toxic and can lead to death if not treated properly. Basically, just kind of a worst case scenario here on lab A, and then a best case on lab B. Just kind of how being prepared led to a much safer accident whenever it occurred. So, and then sometimes accidents just occur without anybody's fault, really. This one was just a bottle of hydrochloric acid that was being shipped into this lab, and they opened the box and they were picking the bottle up by the handle, and then the whole bottle just collapsed and broke. And so they had a 2.5 liter concentrated hydrochloric acid spill. So accidents occur, you just have to be prepared for them. You know, if you need help, if it's an emergency, definitely call 911 or the police. But if it's an urgent need, which would be kind of a spill that's not causing or likely to cause immediate harm, then you can call us at the 974-5084. But do not leave a message. If it's after hours, then call the police line. We have an on-call person, and they can contact us after hours. And then, so kind of go over just real quickly training requirements. And again, we'll give the slides to you, but basically the general lab safety, and then there's the link here, and that's on Canvas. So we do allow self-enrollment on all our Canvas courses, so you can just sign up and then take the trainings that are required by your PI. But we do want people to at least have the general lab safety training, and then any other lab specific training as needed. Uh, One of the major ones that we see that people don't get often is the hazardous waste training. So that should be anyone that either generates or transports hazardous waste needs that hazardous waste training. And that's, again, offered on the EHS Canvas site. And then kind of here's the safety contacts for lab safety services here. And that's all I have. Thank you.
Okay, thanks, Scott. So I will put all of Scott's slides on our Canvas site. He sent them to me beforehand. Let me make a few comments. So the way we control our lab spaces and lab training is, who's online here is Galaxy S9. Scott controls keys, and when you have a key request, they have to go through him. And there's certain training that's required for every laboratory. So he keeps a spreadsheet of who has access to every laboratory, and only after you've completed your training will he give you a key to give you access to that laboratory. So that's the normal process of getting into a laboratory. You know, if it has compressed air in it, or compressed gases, you might have to do compressed gas training. If it has radioactive materials, there'll be some lab safety training. So just give you a heads up on how all that works. But our goal, again, is the same as Scott's goal, is to make sure that everybody is safe when they're working here. That's our number one priority. If you look at our strategic plan, our number one priority is to instill a safety culture into our students. And part of that is making sure that our students stay safe. If you're ever doing something that you don't think is safe, stop it, put yourself in a safe mode, talk to your PI. If you still don't think you're safe, come talk to me. We'll talk to EHS. We'll figure it out together. And if you see someone else doing something that's not safe, it's your responsibility to tell them, what you're doing isn't safe. You should stop immediately and backtrack, find out how you can do that in a safe way. So we're all here to protect ourselves and to protect each other. Okay, I'm going to pass it on to Dr. Lukosi. Let me pop up my bio so I can give him a proper introduction. Dr. Lukosi earned his BS in Physics and Astronomy from Benedictine College in 2007. He then attended the University of Missouri-Columbia and earned a master's in 2008 and a PhD in 2012 in nuclear engineering. He then went to the University of Tennessee, joined our faculty here in nuclear engineering. He's currently an associate professor. And during the pandemic, Eric is helping the department design its health safety plans for the faculty, staff, students, and is now going to provide a little bit of an overview of the developed plans. Eric, thank you.
Yep, thank you. Thank you, Marsha and Scott. I appreciate it. So as Dr. Hines said, I'm going to be talking about the phase 3 safety plan for the nuclear engineering department, specifically geared towards our students. So I'm going to go over general etiquette, everything that you should have already know, but it never hurts to repeat. We'll talk about staffing in our department, office spaces and other shared spaces, and then we'll talk about research labs. So everybody should be aware that they need to do the self-screening before they come to campus. There's just 5 questions, and make sure that you put your supervisor's email on the submission before you submit. And if you click yes on any of those questions, the email will give you specific guidance on what next steps that you need to do, such as filling out a self-isolation form. And of course, UT, the Incident and Command Center, will follow up with you. Now, when you're on campus, you need to wear a mask at all times when you're in common spaces, and you need to maintain 6-foot physical distancing at all times. So if you're outside eating lunch, and nobody's near you, obviously you don't need to be wearing a mask, but if you're in your hallways or a shared office space, you must be wearing a mask. Please wash your hands or use hand sanitizer after touching common surfaces, being in common areas, before eating, and before and after using the restroom. Some people on campus, even students, could have some comorbidities that make them more susceptible to complications from a COVID-19 infection. So just please be respectful of others and their comfort level on how close you are and how you interact with others. Please follow the vols help vols guidelines from the chancellor's office, and avoid large gatherings on and off campus. Let's not follow the UNC model. Let's stay open this semester, and it's going to take everybody doing their part to have a safe and productive time this fall on campus. And also, if you're congregating in the halls, even if you're 6 feet apart, just be aware that classes might be ending, and so try to avoid any unnecessary traffic jams and try to find a more open space if you're talking outside of a shared office space. And naturally, as Dr. Hines just said, we need to encourage others to follow these protocols and general lab safety protocols, so everybody is as safe as can be as part of our strategic plan. And I believe that the water bottle fill stations are on, but the water fountains should be turned off. So you should be able to get water in the hallways. So everybody needs to interact with the nuclear engineering staff from time to time. Most of this can be done over email or a phone call. So try to do that if at all possible. But if you do need to meet with the staff, this table here lists who will be present on what days and at what times. So our business manager, Pam Elwood, our front office, Michelle McBee, undergraduate advisor, Amanda Lovelace, Scott Emmert can help you with any lab specific information like dosimeters, moving equipment, using the machine shop, Ashley Pearson for IT support, and then Gina Hale for HR. And I'll show a slide a couple down that you can find this information on the main UTNE website. So there are still open office spaces as far as I'm aware. I and Scott went and looked at all of the office spaces that that are under our departmental control, and we've identified what requirements for each office space are to maintain UTK and CDC guidelines for physical distancing. So if you are assigned an office space, be sure that you're wearing a mask at all times. These buildings, specifically Ferris and NEB, have very poor air handling systems. And so there's not a lot of air exchanges. And so there could be static contaminants in the air. And so we want to make sure that we minimize those contaminants by wearing a mask at all times. And so here's just a design as an example for Ferris 215. And there's 3 to 4 different colors on each design. So if the office desk labeled here is 1 is green, that means that you can be in that space at any time. If they're blue or red, this means that you need to have a staggered schedule. So for instance, desk 8 could have an occupant from 8 a.m. to noon, and then the blue desk at 7 and 10 could have occupancy between 1 and 5 p.m., or you could stagger them by days. And this needs to be designed with the responsible faculty for that office, which should be your supervisor, since most office spaces try to congregate all of their graduate students together. And then there are some desks that should not be used. So this is for general guidance. If you want to change the design, I'm okay with that. Just please contact me and Ashley Pearson so it's well documented. And it's very important to make sure that you don't squat in any office spaces without having a proper assignment, because it will be important for contact tracing. No eating or drinking is allowed in these office spaces. They should only take place in an outdoor location where you can be physically distanced from others. You should clean your desks. If you need more cleaning supplies, please let myself or Michelle McBee know so we can order some more. So be sure to clean your desk spaces often. As far as eating goes, the kitchen on the first floor in NEB is open, but there should be no more than 3 persons allowed in there at a time. And you should clean the surfaces before and after you use the microwave, any tabletops, and the handles to the refrigerator. And there should be markings outside of the kitchen area that are 6 feet apart to form a line if there's a lot of people trying to eat lunch around 12, 1 o'clock, which is possible. Okay, so there's a study room and a lounge that was designed for undergraduate students, and this year we redesigned them to be landing zones. So priority is given to students who need a space to do synchronous online learning in a scenario where they are not able to go home right after, let's say, a class, for instance, a face-to-face class. So there's a total of 28 desks available in NEB 109 and FAIRS 212 that meet the 6-foot physical distancing, and it has the same rules as the shared office spaces. You must wear a mask at all times. No eating or drinking in these spaces. There should be plenty of power outlets. These desks, you might have an issue, so be sure if you need to charge your laptop that you get one along the walls. And you can schedule this through a website that I designed, and then Dr. Coble and Ashley Pearson helped set up a Google Calendar, and I'll show you how that works here in just a second. So if you go to the main UT webpage, you'll see here, this will tell you what the staff scheduling is, and this can change, so be sure to check it from time to time if you need to have physical interactions with our staff, because if there's shutdowns with UT Knox County, I have kids in elementary school, and that might change my schedule, and there's other staff that might have the same situation, so just be sure to check that. If you would like to reserve an area or a desk in one of these landing zones, you'll see this blue box over here. You'll want to click on this hyperlink, and it will take you to the web page. This is the use policy. So this space is for UTNE students only. And in addition, you cannot move the desks around. You cannot share desks. You cannot have collaborative work, because that would violate the 6-foot minimum physical distancing requirement, okay? Now, if you want to schedule a room, you'll go up here and click reserving a desk. Also note, I have 2 links at the very end of this presentation, and they're also here on this ribbon to get active real-time monitoring of clusters on campus, and the number of active infections and self-isolations, as well as general information for students and staff about COVID-19 practices and policies on campus. So again, you'll click this reserving a desk. You will see this web page here. And you already saw the design for NEB 109, which is farther below in the web page. Here's the design for FAIRS 212. And so you'll just want to identify which desk that you want, and then click on the hyperlink, and it will take you to a Google Calendar, and it will tell you what desks are available. So right now it is underutilized. So if anybody needs these spaces, feel free to use them. It is designed around the UT timetable of classes for fall 2020. So it lines up well with class, and it's 10 minutes before and 15 minutes after the scheduled start and end times of those classes, to provide enough time to get settled in and pack up after your class ends. Now, when you schedule this, it will send you a calendar invite. So you will be reminded that you have scheduled this space, but and if you schedule a desk, it will not show up that you have scheduled it. It will just disappear from the calendar. So your personal information about where you will be and when will not be publicly available. And if you need to schedule a desk, let's say every Tuesday, Thursday over the course of the semester, you can try to do this manually. But Dr. Coble and Amanda Lovelace have stepped up and said that they can help you with this scheduling over the semester to save you a little bit of time. And you can get their emails just by clicking these hyperlinks. Now, research labs, the same general etiquette guidelines apply to research spaces. Obviously, no eating or drinking in the labs ever. So, we should know a lot about this. Marsha and Scott already gave the outline of safe conduct in the research spaces. Your advisor is specifically responsible for setting up the guidelines for activities in each research lab space. So there should already be a phase 2 or phase 3 safety plan that's been designed. There shouldn't be more than 2 or 3 students probably in a research lab at any given time, because we need to maintain 6-foot physical distancing. You need to be wearing your mask. And any research activities that are going on should be prepared for rapid hibernation in the event that the UTK campus goes virtual and stops research activities, or Knox County imposes additional restrictions. I've been told informally that if UT goes all virtual for classes, that research labs will most likely remain open, just like it did in the late spring and early summer for several research labs. So rapid hibernation means if you need to shut down in 24 hours, you need to think about this when you plan your research activities with your supervisor, so you don't lose 6 months of work, okay? and a checklist that's been prepared by probably EHS or the Office of Research for hibernation can be found at this link. I'll share the slides with Dr. Hines so he can put it on the Canvas webpage as well for your review. A couple of things that I wanted to outline that I think is more common in our labs is chemical and radiological. So ensure that compressed gas cylinders have been disconnected and capped if not connected to essential equipment. You know, we are in a seismically active area, and so we always need to make sure that we're storing these cylinders secured well against a wall and with no potential for creating a missile hazard. There's a lot of stored energy in those cylinders. We also know that Strong Hall had an issue with an old laptop where a battery caught fire to the building and flooded it. So, so if you go into a hibernation state, make sure that you unplug any equipment that could potentially cause a fire hazard. And then follow general procedures for chemicals, making sure that they're properly stored, that all chemicals are closed, that there's no open chemicals that are not currently being used in some specific chemical process. And of course, all of that should always be labeled. Fume hood sashes always need to be in the fully closed position when not in use. And this includes during hibernation. Make sure that you get rid of any peroxide forming chemicals or other hazardous chemicals that will expire during a planned hibernation. So that's it for chemical. And for radiation safety, radiological hazards, this is just the general protocols that you should be following anyway. If you're not actively using a radiation source, it should be securely stored within its storage container, typically a cabinet or a safe, and this is all approved by radiation safety already. Contact radiation safety for removal of radioactive waste containers. So we don't want to leave that contamination or the contaminated waste in the laboratory for an extended period of time. So if hibernation occurs, just be sure to get contact Marsha in her office to get dispose of that material. And if you're working with open sources, make sure that you survey the room to make sure that there's no contamination in the room. And if there is, that you properly clean that contamination up following the protocols that have been defined and approved by radiation safety, because we don't want to leave that contamination over an extended period of time. And then if you are badged, well, you should be badged and wearing your badge. Be sure to return those dosimeters if the hibernation period is expected to extend past the end of the monitoring period, which is quarterly. So again, if you have any additional information or if you want additional information, you can find it at that website that I showed that links to these two. You can always send me an email if you have questions later. And the rest of the faculty, the staff, and department head are all here to make sure that we have a productive and fun fall semester in this pandemic. Thank you.
Wow, that was great, Scott, or Eric. I think everybody realizes that the department chose the right person to lead that. Eric, Dr. Lukosi has put in a lot of time and work and effort, making sure that everything is done exactly the way it's supposed to be done. He mentioned, let's don't be a North Carolina and get shut down. I think everybody needs to take personal responsibility in this, and hopefully you are. I saw a news brief yesterday, Ohio State sent home 224 students. So when you saw that our chancellor was looking at dismissing, 4 students, thought, oh gosh, that's so tough. 228 students already at Ohio State. So let's make sure we continue to do the right thing. In nuclear, we always want to be the leaders. We want to be the best. Let's continue to do that. I'm going to go ahead and open it up to questions. So in doing that, I'm just going to unmute everybody. So if you have a question, feel free to unmute and state your question. Let's don't all rush in at once.
Seems like y'all covered everything.
We try.
So the those 2 study spaces that we opened up, the landing zones, the priority is for people who have online classes. You know, we had a lot of discussion before the semester that what if students don't have enough time to get from campus to get back home, you know, to tune in for their online class. And especially, you know, undergraduate students who might not have an office where they can sit down and hook into power. So we set that up really to give priority to people who have an online class. Something else, I was just reading the chat at the same time, says we can't unmute ourselves. So hopefully everybody has the ability.
Thank you. You unmuted me.
Okay, great.
Yeah.
Question?
Yeah, I have a question. Just I guess is there a place like we can eat in the nuclear engineering building? Because I think I go to campus Tuesdays and Thursdays because I have like 3 classes throughout the day, and like I often pack lunch, so like I'll put it in the fridge.
Yeah.
I know I can't eat in the office space.
Yeah, so the university policy is no one eats inside. So
Okay.
they say, isn't that right, Dr. Lukosi? Everybody's supposed to go outside. If it's raining hard outside, I don't know what you do. You find some place that has a roof over your head, I guess.
Yeah.
That's the policy that's been put down, is that no one's supposed to be eating in the building, in any buildings.
Thank you.
Yeah, good question.
Yeah, I really think you're not supposed to be eating inside if you are in any space that is a shared location. So, you know, if you're in a private office, that's a different story. But, you know, that's unlikely for most students. So yeah, it's outdoor eating. And, you know, I'll think about other potential solutions and run it up the chain to see if I can come up with something to help out, because, you know, in the summertime, this is not that bad of a situation, but when it comes to October, November, and starts getting chilly, everybody wants to eat outside.
Yeah, I think we're getting real skinny because none of us will be able to eat. It's like, do I want something to eat or do I want to lose a toe to frostbite?
Yeah.
I'm reading some of these other chats. Okay.
Karen Coop, I just unmuted you.
Thanks so much. So just to follow on point with that, even though it seems like it's not an issue, the other day, I guess it was Thursday, it was actually raining outside, and I was sitting on the ground in some random place with people passing by while I'm like putting up my mask and then taking it down, because when it is raining, it's actually really tough to find a place outside. So if we could get some sort of like just a covered umbrella or anything like that to eat, that would actually really help people, especially if we're commuters coming on site for a full day.
No, that's a good point. So
Yeah.
Dr. Lukosi will make that an action item to try to find out how, you know, he's on a college committee, so he can look at best practices that are being used in the college and across the campus, and we'll see if we can find some type of a solution. You know, another thing is that if you're a student, you don't have any, I think the overall, you know, thought is that we should all try to minimize our time on campus, you know, as much as possible. If you don't have to be here, there's no reason to be here and increase your risk. That's something you need to talk to your supervisor about. If you're doing computational, you know, research where you can do it from your home behind a computer and you don't have to do it from your graduate desk behind a computer. You know, we've let people take university computers home to try to increase safety. Those are things you have to talk to your advisor about. And it's really, you know, the advisor gets to make that decision. If you have a big problem with that decision, if any of you have underlying health concerns and you don't feel secure with being on campus, you need to let your supervisor know. And if you're not getting the response that you think you should get, then you can come to me. I really think we have fabulous faculty here that are caring, and I think that that the faculty are going to help you come to a solution that should make you happy. Does anybody have anything else? Okay, well, let's all be safe, and thanks Scott, Marsha, and Eric for providing us some insights. Let's have a fabulous semester. Take care. Bye-bye.